Psoriasis is a chronic, relapsing, and remitting inflammatory skin and joint disease that has an overall prevalence of 2 to 3% worldwide. It typically presents as a well-demarcated erythematous raised lesion with silvery scales affecting the extensor surfaces, mainly elbows, knees, and other parts of the body, significantly affecting the quality of life of patients. What causes psoriasis, and what do we know about the disease? Although the exact etiology is unknown, psoriasis is thought to be resulting from an interplay of environmental and genetic factors. Recent evidence suggests that the initiation of psoriasis is associated with the innate and adaptive immune system. Any infection or injury to epithelial skin cells triggers the release of cytokines and may trigger the activation of dendritic cells expressing self-antigens, which then migrate to draining lymph nodes. Within the lymph nodes, dendritic cells present the self-antigen to naive T cells, and an immunological synapse is established through major histocompatibility complex and T-cell receptor interaction, and ALCAM binding to domain 3 of CD6. This results in T-cell priming, activation, and differentiation to Th1 and Th17 effector cells. The effector cells recirculate and slow down in skin capillaries. The activated cells expressing Th17 and Th1 then emigrate to the skin, where they are represented to autoantigens by dermal dendritic cells and are stimulated further to release more Th1, Th17 cytokines such as interferon gamma, TNF-alpha, interleukin-6, 17A, 17F, and 22. This causes further infiltration of T cells and results in keratinocyte proliferation and plaque formation. Treatment of psoriasis mainly aims at limiting lesions and improving the patient's quality of life. Itolizumab, a humanized IgG1 monoclonal antibody, has shown promising results in psoriasis. Unlike other drugs that target the downstream immunopathogenesis process, itolizumab acts upstream by binding to domain 1 of CD6 without interfering with ALCAM binding to domain 3 of CD6. This downregulates the subsequent processes, that is, priming, activation, and differentiation of T cells into Th1 and Th17. Itolizumab significantly reduces T cell proliferation along with substantially downregulating chemokine and cytokine production. This downregulation of the downstream processes, rather than complete inhibition, brings about a reduction in the ongoing inflammation and ensures better safety and normalization of the skin architecture. Subsequent blocking of the continuing inflammatory process results in long-term remission of psoriatic lesions. Thus, as you can see, itolizumab works as an immunomodulator rather than as an immune suppressor. Thus, itolizumab, with its unique mechanism of action, results in normalization of skin, provides superior safety, longer remission, and brings about an overall improvement in the quality of life of patients with psoriasis.